Hello, I'm Keum from KAIST. Today, I will present my paper, Private Investigator, Extracting Personally Identifiable Information from Large Language Models using Optimized Prompts. Language models are showing unprecedented performance on diverse tasks such as translation, healthcare, and code generation. To obtain high performance on various tasks, language models should be trained with various domain-specific datasets. And these datasets could include personally identifiable information, such as personal name, email addresses, phone numbers, and physical addresses. Unfortunately, these models can memorize such PII items, and they could be extracted by an adversary. Such an attack is called PII extraction attack. It imposes a critical threat on language model ecosystem, and the threat increases as more numbers of fine-tuned language models are shared and used over time. Prior work utilized various prompts to induce the language model to output PII items. As a prompt, prior work utilized simple tokens such as start of sentence token and empty token. Also, they utilized outsourced text such as arbitrary piece of text from the internet. In short, prior work utilized simple or outsourced prompts, and this is a key limitation of prior work. And it leads to this question: how can a smart adversary generate a set of prompts to extract more PII items? To answer this question, we propose an attack framework, Private Investigator. Private Investigator is based on two ideas. First idea is that the prompts effective on surrogate model will be effective on target model. Also, we further prioritize promising prompts during extraction using intermediate extraction results. And these ideas are reflected on prompt generation phase and PII extraction phase. To generate prompts, we first collect promising prompts which extract a large number of PIIs from the surrogate model. For all tokens in the surrogate model's vocabulary, we count the number of PII items induced by certain prompt by generating fixed number of outputs. Then we select the top 1% tokens with the highest ability on inducing PIIs. Among these promising prompts, we first select the most promising prompts with the highest number of extracted PIIs. Then we select a prompt with the longest distance in the hidden space from the previously selected prompt. We repeat this process iteratively until we collect 20 prompts, so that each selected prompt cover a different area in the hidden space, and the set of prompts can trigger diverse contexts on the target model and finally elicit diverse PIIs. Using these prompts generated by the surrogate model, we now extract PII items from the target model. We conducted an attack campaign consists of 100 sequencer PI extraction attempts. Each attack attempt used one prompt to generate 2000 output texts and collect PII items from the texts. We could give same chances on each prompt. However, to effectively conduct this attack campaign, we must effectively select a prompt for each attack attempt. This can be viewed as classical multi-armed bandit problem. So, inspired by the seed selection strategy in fuzzing algorithms, we propose a prompt selection strategy which select the most effective prompts on current extraction attempt based on the extraction results so far. More specifically, we use prompt scoring function, which consists of exploration term and exploitation term. Exploration term gives more chances on less selected prompts, and exploitation term gives more chances on the prompts which induced promising PIIs. And the promisingness of extracted PII is measured by its perplexity. For evaluation, we extracted email addresses, phone numbers, and personal names from 4 language models fine-tuned on 2 email record datasets, unknown and track. To show the effectiveness of Private Investigator, we counted the number of extracted PIIs for the fixed number of queries. As a result, Private Investigator extracts more than 6,000 emails and 36,000 names from Phi2 model fine-tuned on unknown dataset. And it is superior to the state-of-the-art PII extraction attacks. We also counted the PII items exclusively extracted by each attack. This shows that the Private Investigator extracts the largest number of exclusive PIIs that the other methods fail to extract. We further analyzed what makes Private Investigator outperform the baselines. More specifically, we want to know why the prompts made with the surrogate model works on the target model. For that, we deeply investigated the target model's hidden state. We defined PII eliciting direction, which is a vector in the hidden space. It is calculated as the difference between the hidden states of PII inducing prompts and those of non-inducing prompts. So this vector is linked with the capability of inducing the language model to output PII items. When we measured the similarity between the prompts and the PII eliciting direction, we found out that the Private Investigator generated prompts are more aligned with the PII eliciting direction compared to all other prompts. For mitigation, we adopted deduplication and differential privacy. Deduplication is a data pre-processing technique which removes repeated chunk of text from the training data so that it makes the language model hard to memorize the verbatim text. Differential privacy is a technique applied on the training phase that bounds each data sample's impact on the model's behavior. Specifically, we adopted DPSGD, which add noises on the gradient on the stochastic gradient descent method. In the result, the numbers of extracted PIIs are significantly dropped. However, Private Investigator still extracted about 8,000 personal names. Furthermore, this mitigation strategy degrades the model performance significantly. The perplexity of training data on each model rose significantly. It means that it requires stronger and more realistic defense method to secure private information against private investigator. In conclusion, we propose Private Investigator, the first prompt generation framework that induces a target language model to emit memorized PIIs. Private Investigator identifies more and exclusive PIIs compared to state-of-the-art training data extraction attacks. Also, Private Investigator is applicable to testing the vulnerability of a target language model to PII extraction attacks. Thank you, and please refer to our paper and artifact for more details.